The Hall County School District is excited to announce the release of our Back to School ELA and Math Reconnect broadcasts. Between August the 12th and August the 21st, the Hall County School District plans to release 6 ELA and 6 math video lessons for students in grade bands kindergarten through 2nd grade, 3rd grade through 5th grade, 6th grade through 8th grade, and high school. Along with the video lessons, students and parents will have a list of supplemental resources related to the topic from the lesson. Students and parents can access these videos and resources on the district's Reconnect Hall website beginning August 12th. We hope students and parents find these instructional tools helpful in getting a jump start on learning for the upcoming school year. Welcome, and thank you so much for taking the time to get ready for the new school year in Hall County. The following reminders are super important as you begin working with me on this video. Use the resources provided to further your learning. Access supplemental resources using the link below the video. Resources that require a connection to your Hall County Google Drive account are noted on the list. Pause the video when needed to think about what you are learning. You may even ask yourself these questions. Do I know this already? Is this new information? Who taught me this in the past? Today's lesson is going to be on slope. The standard we're going to focus on is about understanding the connections between proportional relationships, lines, and linear equations. We're going to look at graphing proportional relationships, interpreting the unit rate as the slope of the graph. We're going to compare two different proportional relationships represented in different ways. Then we're also going to use similar triangles to explain why the slope m is the same between any two distinct points on a non-vertical line in the coordinate plane. And then the rest of that standard we're going to focus on later. Derive the equation y equals mx for a line through the origin and the equation y equals mx plus b for a line intercepting the vertical axis at b. You and I are going to work to tackle the following learning targets, or goals, in this video. The learning targets we're going to focus on are to relate similar triangles to slope using different points on a graph. We're going to relate the unit rate to the slope of a function line. We're going to interpret a situation to determine the rate of change. We're going to understand the unit rate slope relationship in equations, graphs, and tables. Again, remember, don't be afraid to pause the video if you need a minute or two to think. Just make sure you come back when you're ready and finish the lesson. Before we really investigate and accomplish these learning targets, let's try a warm-up. In these 4 problems, I want you to remind yourself how to combine like terms. So I want you to combine like terms below to simplify the expressions. Go ahead and pause the video, work this out, and I'll see you in a minute. All right, welcome back. Let's see how we did on the warm-up. So in number 1, we have 2 sets that we can combine, right? We have the 2x and the 1x, so that makes 3x. And then the positive 4 and negative 5. If I combine those together, I get negative 1. So 3x minus 1. In number 2, there were a few things we needed to look at. First, we needed to distribute the 4 to the x and the 7. So you can see I showed you that step. That was 4x plus 28. And then I just brought down 3y minus 10. When I look at that step, I can see that I only have one x term and one y term. I can't put those together because they're different variables. So I have 4x plus 3y. But then I have 2 constants. I have 28 and negative 10. And a positive 28 minus 10 is a positive 18. So 4x plus 3y plus 18. In number 3, we had some distributing to do as well, so we're going to distribute that negative 2 to the x and the negative 3. So that's negative 2x and the negative 2 times the negative 3. Remember your rules. A negative times a negative is a positive, so negative 2x plus 6, and then I brought down the plus 5x minus 6y. In this equation, or expression, I can put the x terms together, the negative 2x plus 5x, and that gives me 3x minus 6y plus 6. And lastly, in number 4, if I look through that, the a term I only have one of, but then I have two constants and two b terms. So I'm going to go ahead and bring down the 7a, and then I'm going to combine the positive 2b and the negative 6b to give me negative 4b, and the positive 3 and the negative 5 give me negative 2. So I hope those made sense to you. Let's keep going and see what we can get into. Let's look at the mini lesson for today. We're going to focus on what is slope. And I want you to think about what you think of once you envision if I say the word slope. Do you think about a ski slope? Do you think about a ramp? Do you think about a roller coaster? All of those have slopes, and slope refers to the steepness of a line. Well, in math, we use the letter M to represent slope. So if we're finding the slope, a lot of times we would write M equals and list the slope. To help find the slope, we can find the change in y over the change in x. You're going to hear that a lot, the change in y over the change in x. So I've given you a little graphic at the bottom where slope equals, and I've written out those words, change in y over the change in x. Sometimes we use this little triangle, and that's called a delta symbol, and that's red, change in. So that little triangle y really says change in y over the change in x. All right? So we've got a line over here that has a specific slope that we're going to learn how to calculate. All right, so previously you guys have talked about constant rates of change. That should sound pretty familiar to you. Well, slope is a constant rate of change. Constant rate of change in the graph and table to the right is 60. So for every 1 hour, the family travels 60 miles. So if you look at the graph with me, I've got the Williams family road trip, and it shows the time on the x-axis and the distance in miles on the y-axis. So I'm going to find that the constant rate of change is for every 60 miles they travel, it takes 1 hour. So that's the constant rate of change. Well, it's also the slope. So you can see the slope on the graph. You can see that I go up 60 and over 1 every time. But if you'll look in the table, we can see that as well. Remember, change in x and change in y is just how they change from one to the other. So the hours are going up by 1. That's the change in the x. And the distance is going up by 60. So that's the change in the y. So for every 60 miles, it takes them an hour. Or every hour, they drive 60 miles. The slope is visible in both places. And so when we calculate the change, the constant rate of change is the slope of the line. That's just another way we refer to it. Let's look at it in this situation. To find the constant rate in the table, remember, you're going to find the pattern in the x values and the pattern in the y values. And our goal is for it to be the constant pattern. If it's not constant, we may have to look at something a little trickier. So in the example to the right, the change in the y values is negative 2. So from negative 12 down to negative 14 down to negative 16 is going down 2 every time. So we represent that as negative 2. Well, the change in the x values is 1. From 1 to 2, 2 to 3, and 3 to 4, the constant change is 1. So if I'm going to write that as a slope, remember the change in y over the change in x. Well, what is my change in y, or my constant change in y? It's negative 2. And what's my change in x? 1. And negative 2 over 1 would be a slope of negative 2. All right. Here, I want us to tell whether the rates of change are constant, or if they're variable. That means they change. Then they're not constant. So if I look at that top problem, if I look at the change in x, I have plus 2, plus 3, plus 1, plus 2. That doesn't sound like it's constant. Let's look at the y's. Plus 6, plus 9, plus 3, plus 6. Well, that doesn't sound very constant either. Well, what I'm going to do is I'm going to write the change in y over the change in x every time. So here, the change in y is 6, the change in x is 2. 6 over 2 equals 3. Well, here, the change in y is 9, over the change in x is 6. Well, that still simplifies down to 3. Well, change in y is 3, change in x is 1. That's still 3. Change in y is 6, change in x is 2. That's still 3. So this actually is a constant rate of change. So for every time the y's go up by 3, the x's go up by 1. So this is a constant rate of change of 3, or a slope of 3. Our table just skips some values along the way. So you have to pay attention to that. Remember, I said it could get tricky if it didn't look constant. You might have to investigate it a little bit more. So in this case, when we really looked into it, it is a constant rate of 3. All right, so what I want you to do is I want you to find the constant rate of change, or now remember, it's called the slope, for each of the above tables. So there's 4 tables above. I want you to find the constant rate of change. Remember, change in y over the change in x. How does the y change? How does the x change? Write it as a fraction. So I want you to go ahead and pause the slide to complete this activity, and I'll see you again in a minute. All right, welcome back. So let's look at the work together. So let's talk through this and see what we can figure out. All right, so this set of blue boxes here is the rate, or the constant rate of change for this table. So for every time the x goes up, it's plus 1, right? And the pattern in the y is a plus 4. So 4 over 1, change in y, over change in x is 4. All right, these orange boxes go with the next one. This pattern in the y's is going down 4, so negative 4, right? And the x is going down 6, subtracting 6 every time, right? So change in y is negative 4, over change in x is negative 6, and that simplifies down to 2/3. But wait a minute, why isn't it negative? Well, remember, 2 negatives make a positive in our integer rules, right? And so negative 4 over negative 6 makes a positive. All right, the third one, change in x is plus 2, change in y is a positive 5. So is it 2 over 5? No. Remember, we want to go change in y over change in x, so 5 over 2, and that doesn't simplify. And then the last one, change in y is 4, change in x is 2, and 4 over 2 is 2. All right. I hope that made sense. If it doesn't, you may want to go back and look at the examples we talked about before moving forward. So what if the table looks like the table to the right? Can you find the slope? Well, the change in the y values and the change in the x values aren't constant for the whole table. Does this mean it doesn't have a constant rate of change? Well, remember what we talked about before. I can write those common ratios, right? So even though in part of the table the rate of change is 4 over 2, so the first two jumps, 4 over 2, 4 over 2, and then it jumps to 30 over 15. Well, that's not what we've been used to, but both of these ratios, 4/2 and 30/15, they simplify, and they both simplify down to 2. So the table does have a constant rate of change. Alright, so when a table shows a constant rate of change, you can complete the rest of the table. So what I want you to do is I want you to complete the 2 empty spaces in this table using your constant rate of change. So go ahead and pause the video, complete the activity, and I'll see you in a minute. Alright, let's see how we did. Did you get 12 and 17? I hope so. The constant rate of change in the x is plus 2. And the constant rate of change in the y is plus 5. So if that's the case, we're looking at this same table, what's the slope? Well, think about it. Change in y over change in x, so it's 5/2. Good job. Let's do another one. So complete this. I've got 3 blanks for you this time, so make sure you fill in the 2 blanks in the y and the 1 blank in the x. Go ahead and pause, and I'll see you in a minute. All right, so Change in x is going down by 3 every time. The change in y is adding 6. So these should be the answers that you got. So what is the slope? Well, remember, change in y, change in x. So it's -2, right? 6 over -3 would make it -2. All right, let's talk about slope and switch gears just a little bit and talk about 4 types of slope. This is going to be important to remember as we start finding slope on graphs and when we're looking at things. So there are 4 types of slope: positive, negative, 0, and undefined. So I want you to look at those and think about what you envision when you see those 4 types of slope. I kind of like to tell a funny story about going to a ski slope. I think about ski slopes when I think about slope. And I think about this positive slope right here. This reminds me of the ski lift. On the ski lift, I'm really excited. I am positive I am going to be the best skier in the world. Right? I'm excited, I'm positive. I'm going up the ski lift. Well, when I get off the ski lift, I turn a little negative. So when I'm going down the slope, down the ski slope here, I don't think I'm the world's greatest skier. In fact, I don't think I'm very good. So I'm really negative about skiing probably when I'm going down the hill. That's what I want to think about with positive and negative slope. With 0 slope, I think about if I was skiing down this, it would be 0 fun because it's flat, right? So a flat line is 0 fun to ski down, so it's the 0 slope. And then I talk about this. This is called an undefined slope. And if I was trying to ski down this undefined slope, I think they would be unable to find me after I rolled all the way down that very, 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 very steep hill. So I don't think I would want to ski down this one. So that's a no for me. I'm unable to ski that, so it's undefined. This is 0 fun, so 0 slope. I'm really negative about skiing as I'm going down and falling, but I'm really positive going up the ski lift as I'm excited about what's about to happen. So that's kind of what I think about when I think about the 4 types of slope. I hope that helps you as you are learning them. So let's check out this video real quick about the 4 types of slope.
Hey everyone, thanks for joining us on this very short lesson on the different types of slope, which we are going to look at from a skate park. Now we want to develop the skill of being able to identify a slope just by looking at it. Now a positive slope increases from left to right, while a negative slope decreases from left to right. A 0 slope is a flat horizontal line, and an undefined slope is a vertical one. So now let's check out these scenes from a skate park to help reinforce our understanding of what these kinds of slopes look like. That dude is not paying attention.
Alright, so there's just a few more examples of the 4 types of slope. So remember, the positive slope rises from the left to the right. Just like you read, if you look at this graph from left to right, this is a positive slope. A negative slope falls from left to right. So if I'm reading left to right, this is falling or going down. 0 and undefined slope. The 0 slope is the horizontal line, and the undefined line is the vertical line. So what I want you to do is I want you to decide what types of slope from the 4 types of slope these 6 graphs are. So I want you to pause the video, figure out what types of slope is shown, and then come back and we'll check your work together. All right, welcome back. Let's see how we did on naming types of slope. All right, we look at this one. We're falling from left to right. So we're going down. Remember my ski slope. That's where I'm really negative. I'm going to fall. That's negative. This with this horizontal line, 0 fun, 0 slope. Going up from left to right, I'm rising from left to right. That's positive. Here's another positive. And another positive here. And this is the undefined. Remember, I'm unable to ski that, so that is undefined. How'd you do? Hope you got those right. If you need a little more practice, make sure you just look at some examples from the previous ones we've looked at so you can learn those 4 types of slope. So how are you feeling? So we've talked about how slope is also the constant rate of change that we're familiar with, and we've talked about how there are 4 types of slope. Let's keep going. All right, so we talked about how slope is the change in y over the change in x. And sometimes it looks like the triangle symbols with the x and y, so the delta symbols, so change in y over change in x. Well, sometimes it's referred to as the rise over the run. And I want you to think about the rise over the run. You have to rise out of bed in the morning before you can run to school, right? So in this graph here, we can see that this is a positive slope. Everybody see that? Positive? Well, what I want to pay attention to is the rise, or the change in y. I'm going to count from one point to this other point. You see how these are exactly on those grid lines? I want to try to find points like that. So I'm going to try to get from this point to this point. So if I do that, I'm going to rise first. That means I go up and down first. I'm going to go up 1, 2, 3. So my rise, or my change in y, is 3. My run is 1. So I went from 1 to 2 over there. So my run, or my change in x, is 1. So change in y is 3 over change in x is 1. So my slope is 3.
What's up, everybody? Let's go ahead and jump into this introductory lesson on slope. Now, what makes a roller coaster fun is that you are constantly changing direction, whether you're increasing or decreasing at different levels of steepness. And we are going to relate this experience to our understanding of the slopes of lines on the coordinate plane. So we are going to think of the slope of a line as its direction and its level of steepness. Now, portions of a roller coaster with a low amount of steepness result in a slow and gradual change in elevation, while the sections that are very steep result in a rapid change in elevation. So as long as you're not feeling too nauseous, let's go ahead and extend this thinking to our understanding of the slopes of lines. Now, in this lesson, we're going to discuss 2 types of slope, positive and negative. Now, positive slopes increase from left to right, while negative slopes decrease from left to right. We will also be referring to slope in terms of what we call rise over run. So we have a line with points on the line. Now the rise is going to represent how many units up or down we have to move. And the run is going to be how many units left or right we have to move in order to move from point to point. And it kind of makes this staircase image. Now notice that since this line has a positive slope, our rise was upwards and our run was to the right to move from point to point. However, if our line has a negative slope, that is, it decreases from left to right, when we rise downwards. I know that sounds weird, but we're rising in a downwards direction and then running over to the right to move from point to point. So let's take a few moments to visualize the difference between applying rise over run to positive and negative slopes. Again, notice that the line with the positive slope is increasing from left to right, and that the line with the negative slope is decreasing from left to right. Now we can go ahead and take a look at a line on the coordinate plane. Now we want to find the slope of this line in terms of rise over run. So our slope is going to be expressed as a fraction of two numbers. So our rise is the amount of change we go vertically. Our run is the amount of change we have horizontally as we move from point to point. Now this is a positive slope. We can tell by looking at it. It increases from left to right. And we're going to start with the two farthest points away from each other. So we'll start by counting the rise, the number of units that we are increasing, and then the run, the amount of units that we're moving horizontally, again, to make this staircase shape. If we count the number of units upward, we rose 12, and then our run was 18 units to the right. So we can express our slope as positive 12 over 18. However, 12 over 18 can be simplified. We divide those both by 2, we get 6 over 9. That means that if I start from the same point and this time rise 6 units and then run to the right 9 units, I'll still end up on the line, just a different point. This is a more simplified slope, but if I repeat that by rising 6 and running over to the right 9, I do end up in the same spot. So when we find the slope of a line, we always want it in the most reduced form possible. Now 6 over 9 is smaller than 12 over 18, but that can actually be reduced again. 6 over 9 is equivalent to 2 over 3. Now we notice that if we start again at that same point, rise up 2 units, run to the right 3 units, we end up at another point. This time it's the closest point. And if we continue that pattern by rising 2 and running to the right 3, we're slowly building that staircase, but we're also landing on a point on the line each time. So the most reduced form of the slope of this line is positive 2 over 3. Now again, that doesn't mean that the other two slopes, the 12 over 18 and the 6 over 9, were incorrect. They just weren't in reduced form. But all three of the slopes that we looked at will take you from one point on the line to another point on the line. So here's our first example. We want to find the slope of the line that passes through the given points that are shown on the graph here. Now we know that slope is rise over run, so we want to find the rise over run between those 2 points. So let's go ahead and build our staircase. This line has a positive slope, so I'm going to rise up a certain number of units and then run over to the right to get from point to point and then count. My rise is 6 and my run is 3. Now I'm almost done, but 6 over 3 can be reduced because 6 divided by 3 equals 2. And we want to think of slope as a fraction in terms of rise over run, so we're going to express it as 2 over 1. So if we go back to the starting point, if we rise 2 units up and run to the right 1, we end up on the line again. And if we continue this, rise over run of up 2 and going over to the right 1 and building that staircase, we continue to land on points that are on the line. So the slope of this line in reduced form is 2 over 1, which we are just going to express as 2, since 2 over 1 means 2 divided by 1, which just equals 2. This last example is just like the last one, except now we're dealing with a different line. Now notice that this line decreases from left to right, so its slope will be negative. So now we want to find rise over run between those 2 given points. Since the slope is negative, we rise downward, and then we run to the right to make that staircase image. And then we can just count. So the rise downward was 3 units, and the run to the right was 8 units. So the slope of this line is negative 3 over 8, which cannot be reduced, so that's going to be our final answer, the slope of this line. Cool, cool. Thank you.
All right. So that was kind of a compilation, an overview of what we're going to be talking about. We're going to look more in depth at the rise over the run. So let's talk about how to calculate slope using the rise over the run. We talked about it a little before the video, and the video showed us as well. So when you have a graph, you can create those similar triangles and use that rise over the run. So sometimes they call rise the fall if you've got a negative line, but really it's still the rise. You just might be rising positively or rising negatively, which is kind of like falling. So to do this, you're going to pick the point on a graph. It doesn't matter which point, but we do want to pick a point that lies directly on the intersection of those grid lines. So for this problem, I just picked this point and this point. So we're going to try to get from here to here. Now, you can see that I drew an arrow up because I rose, and then an arrow right because I ran that way to that point. I could have chosen to go down and left, but I would have been dealing with two negatives, and I just decided to keep it positive so I didn't mess it up. So we're going to rise 1, 2, 3, 4. And then we're going to run 1, 2, 3. So my rise is 4. That's my change in y. My run is 3. That's my change in x. So the slope is 4 over 3. So it's important for us to remember how to move on the coordinate grid, especially when we're calculating using rise over run. So it's important to know how the directions affect the sign of the number when we do this. So I want you to think and remember positive directions. If you're moving up or you're moving right, those are positive directions. Down and left are negative directions. So for example, if you move up 4 units, that creates a positive 4. But if you move down 4 units, that creates a negative 4. And the same thing with right and left. If you were to move right 4 units, it's positive 4. If you were to move left 4 units, it would be a negative 4. So don't forget about the directions on the coordinate grid, especially when we're using rise over run. So how do you feel? How do you feel about rise over run? Let's look at some examples together. So what I want you to do is I want you to look at these 7 graphs, and I want you to calculate the slope of each graph using the rise over the run. Now I want you to remember, you pick 2 points, and in these I picked 2 points for you. Okay? So if I pick 2 points for you, you just pick one to start at, and you move from one point to the other. Remember, rise first, and then run. Up and right are positive, down and left are negative. While it's paused, also feel free to go back and look at how we did it one more time before you try these examples on your own. When you're finished, come back and we'll check your work. All right, let's look at these together. So I've calculated the slope using the rise over the run. Let's look at them together. I'm going from here to here. I'm going to rise 1 and run 1. 1 over 1 is 1. I'm going to fall 1. That's like a negative 1. Remember, down 1 is a negative direction. And I'm going to run 1 right, and so that's a negative 1 over 1. So the slope is negative 1. Here, look guys, I didn't even have to find the rise over the run here because this slope is a 0 slope. So the slope is 0. That's the answer. Here, I can count. Look, it's going to be negative. I know before I even start that my answer is going to be negative because the line's negative. So that's important to check. So I'm going to start at this point, and I'm going to go 1, 2, 3 down, so that's negative 3, and write 1, 2, 3. And negative 3 over 3 is negative 1. All right, let's try this one. It's positive. See, I already know that. 1, 2, 3, 4, 5, 6, 7, and write 1, 2, so 7 halves. This one, don't have to calculate. It's undefined. Remember, it's that vertical line. And here, I'm going to go 1, 2, 3, 4, 5, 6, and write 1. And 6 over 1 is 6. All right, so similar triangles kind of relate to the rise over the run as well. Similar triangles have proportional side lengths. So if you look here, this 4 and this 10, and then this 6 and this 15, you can see we're going to look at proportional side lengths here. So when you look at them on a line, it helps you to calculate the slope. So I've made similar triangles here by adding this point in the middle. So if you go up 6 and right 4, that's going to simplify down to 3 over 2. Well, if I go up 15 and right 10, that rise over run also simplifies to 3 over 2. So those are the same proportional triangles there. So you can use the similar triangles to help you calculate the slope. And the side lengths create those consistent ratios. So this is a video that helps you calculate slope with similar triangles. It's found in your resource guide, so make sure to check it out after this video. So when using similar triangles, we can set up proportions to help find other points on the line. So in the example to the right, the slope is 1/2 using triangle 1, right? And this is triangle 1 here, and the top one is triangle 2. So using triangle 2, the slope is 2/4, which simplifies to 1/2. So the proportion 1/2 and similar triangles would help us solve the following. So 1/2 equals 2/4. That's the proportion that we set up. Well, if we also set it equal, and I know that the change in y is 6, what's the change in x? I could set up this proportion here. Well, 1/2 equals 2/4 equals 6 over x. I can choose either one of these to solve with. So if I just focus on these last two ratios and this proportion here, how I find this, remember, is I cross multiply. So 2 times x is 2x, and 4 times 6 is 24. If I divide both sides by 2, x equals 12. So the change in x, using these similar triangles, is 12 units. All right, let's keep going. If that didn't make sense, make sure you go back and check it out so that you can be with us moving forward. So we've talked a lot about slope, and it's referred to in many different ways. So I want you to look at the graphic to the left. All the terms in that graphic refer to the same thing, slope. Constant rate of change in y over change in x, rise over run, unit rate, the letter m, all of that deals with slope, and it means the same thing. So now that you know how to calculate using rise over run, let's learn how to use the slope formula. Slope formula is the change in y over change in x, but it's written like this, the change in y, so x2 minus x1, that's how the y's are changing, over x2 minus x1, that's how the x's are changing. So I'm finding a change in y over a change in x. It just looks different. So if you're given or can find 2 points on a line, you can use the slope formula to calculate the slope. So, for example, if I'm given the point 0, 4 and -2, -2, it might ask me to find the slope between the 2 points. So it's important to realize that this is the first point it gave me, although it doesn't matter. We have to keep things in the right order. So this is point 1 and this is point 2. You can see that my x and y values kind of correspond to those points. So if this is point 1 and this is point 2, then when I fill in my formula here, y2 is -2 minus y1 is 4 over x2 is -2 minus x1 is 0. So when I work that out, -2 minus 4 over -2 minus 0, well, what happens? Well, when I actually do that subtraction, -2 minus 4 is -6, and -2 minus 0 is -2. I want you to pay very, very, very close attention that integer rules are so important when we're using the slope formula. -6 over -2 simplifies to 3 over 1. Remember, negative divided by a negative. So our slope is 3. So I don't have to have a graph. As long as I'm given 2 points, I can find the slope between them. This is a quick video on finding the slope from 2 points that is in the resource guide. So make sure you check that out when you finish the video, because I think it'd be really helpful for you to learn a little more about slope from 2 points. So again, we've seen this slide before. So we've talked about all the different ways that we can talk about slope and how we can find slope. And it's also referred to as the unit rate, which is a review from before. You found the unit rate of things. So let's talk about that together. I want you to look at the graph to the left to help you investigate this question. Okay? So we're talking about Misty Mountain Storm. Remember, I think about slope and I think about ski lifts. So it's how the snowfall in inches and the time in hours. So the first thing I want you to do is I want you to find the slope of the graph using the points 1, 2, and 5, 10. Remember, the slope is the constant rate of change. Then I want you to find the unit rate of snowfall in per inches. Remember, that's how much the y changes per 1. And then I want you to compare the slope and the unit rate and tell me what you notice. Then I want you to talk to me about what unique point on this graph that you can see right now represents the slope of the graph and the unit rate of change in the snow level. And I want you to explain how you found that point. So I want you to go ahead and pause the video, see if you can answer these 4 parts, and then we'll keep going together. All right, welcome back. Let's talk about the 4 points and 4 parts of this together. So the first thing we're going to do is we're going to find the slope using our slope formula. And remember, that's the change in y over the change in x. y2 minus y1 over x2 minus x1. So here it is. Here's my formula. And then my y2 is 10 minus my y1 is 2 over my x2, or my x from the second point, minus x1, which is 1. Then I'm going to actually solve that. 10 minus 2 is 8. 5 minus 1 is 4. 8 over 4 is 2. So my slope is, you guessed it, 2. Well, if I find the unit rate, that is also 2. You may have used a variety of different methods, but the unit rate is 2, right? So I could find a point on here, and if I use 5/10 up there, if I divide 10 over 5, I'm going to find the unit rate, right? If it falls 10 inches in 5 hours, how much does it fall in 1 hour? Well, it falls 2 inches in an hour. If I compare the slope to the unit rate, what do I see? They're the same. And then which unique point on this graph can represent the slope of the graph and the unit rate? Well, if I go to the point 1, 2, then that is the point that represents both of them. Sorry, I put it in the wrong order right here. It should be 1, 2. So right there is the point that represents both of those. All right, I want you to try one more. This is about a leaking tank. How fast is the tank leaking? So I want you to do the 4 same problems again. You've got different points over here to find the slope formula. So I want you to pause this, see what you can do with this one, and come right back. All right, welcome back. Let's look at this together. All right, so 6 minus 3 is my change in y's, and 8 minus 4 is my change in x's. 6 minus 3 is 3, 8 minus 4 is 4, so my slope is 3/4. Well, the unit rate, remember, here's the point 4, 3, so if I divide that, 3 out of 4, then it's going to be, how long does it change every hour? It loses 3/4 of a gallon every hour. You guessed it. They match, which is what I want them to do. And what about that point? What unique point represents this? Well, it's actually 1/3. Even though you can't see that there, that is the point that represents the unit rate of the slope, because that shows us how it's changing for every one. So based on these last 2 questions, what can you explain about the relationship between slope and unit rate? Well, I hope that you can explain that they are the same. If you can find the unit rate, you can find the slope. All right, so let's do a work session together. What I want you to do is I just want you to practice finding the slope using the slope formula. I want you to show all your work if you can, set up the problem, and go ahead and pause the video. And then when you're finished, come back and we'll check your work. All right, let's see how you did. I'm going to go ahead and put all of my work on the screen. And if you want to pause me to check your work, if there was one that you missed or you didn't get exactly right, I want you to be able to look at your work and see where you might have messed up and what you might need to pay attention to next time. The answer to number 1 is 7/6. 9 minus 2 over 7 minus 1. Going across number 2, the answer is -3/4. So if I do 0 minus 3, and then those integers get tricky, -1 minus -5, which turns into -1 plus 5, remember. In number 3, my answer is -4/5. In number 4, my answer is undefined, and I want you to look at that. If the 0, I like to remember this fun little thing. If the 0 is under the line, and the line is the division sign, so if it's under the line, it's undefined. So I'm just talking about that 0. So 6 minus 6 gives me 0 in my denominator. So if my 0 is under the line, it's undefined. So that's the slope of that line. Number 5, my slope is -1. And number 6, my slope is -6/5. So I hope you got those right. If you didn't, don't forget that video is linked in the resource guide, and you can also go back and look at this work and realize how to set the problem up correctly so that you can work it out. There are a few more practice assignments and games in your resource document if you'd like to practice finding slope with rise over run or with the slope formula a little more, so make sure you check those out. So let's review. Wow, that was a lot of information, wasn't it? Well, how did you do? Let's review what you should have gathered from this lesson. Well, we talked about how slope refers to the steepness of a line. We talked about how the letter M is most commonly used to represent it. We talked about that to help us find slope, we can find the change in y over the change in x, or the delta y over the delta x. We talked about directions too, right? We talked about how up and right are positive directions and down and left are negative directions. And then we finally made the connection that slope is the same thing as unit rate, is the same thing as constant rate of change. We talked about the 4 types of slope: positive, negative, 0, undefined. Remember, you can always think about my ski slope when you're thinking about that. And then we talked about how you can calculate slope from tables, from using rise over run, to similar triangles, to the slope formula. There's lots of different ways that we can calculate slope depending on what we're given. How about our learning targets? I think we did these pretty well. Can you relate similar triangles to slope? Can you relate the unit rate to the slope? How about interpreting a situation to determine the rate of change, like those tables? Or those last questions we looked at? How about understanding the unit rate or slope relationship in equations, graphs, and tables? I hope you got all those learning targets. If you didn't, feel free to go back and review different parts of this video. Well, I really hope that this lesson about slope has been helpful to you. For additional practice and support, check out the resources and activities that have been provided in the resource list linked directly below this video. Know that you can come back to this lesson again and again to further reinforce your learning. Reach out to your teacher if you have any questions. Check out those videos one more time if you have any questions. We're looking forward to a great year thriving together. Thank you so much for watching.